right, I'm gonna go over the homework from the explosions section. If it makes you feel any better, this is my second attempt at this, because even I screwed it up the first time. So, it says you accidentally drop a 3.5 kilogram platter. So you drop it straight down, and when it hits the floor, they want you to imagine the floor has a Cartesian plane on it. It has an XY axis on it. The first piece has a mass of 1.3, and it moves off with a velocity of 1.8 at 52 degrees. I'm not going to write that there. I'm going to write it over here. 52 degrees counterclockwise from the positive x-axis. So here's the positive x-axis. 52 degrees counterclockwise would be here. Now, the mistake that a lot of people make, and even I've done it, is putting the velocity here. But when we talk about explosions, we talk about the momentum right before the explosion or the impact, and the momentum right after. So as soon as that plate hits the ground and the pieces start moving off into other directions, what is the momentum? So what we're going to figure out then is we're going to figure out the momentum for piece number one, which is mass times velocity. And so the momentum is 1.3 times 1.8, which is 2.34. So what goes here is 2.34. Same thing, mass 2 is 1.2 kilograms this time, and velocity 2 is 2.5 meters per second. And it goes off at 61 degrees clockwise from the negative x-axis. So here's the negative x-axis, clockwise would be this way, so 61 degrees. So again, what's going to go here on my hypotenuse is going to be the momentum, which is mass, which is 1.2 times velocity, which is 2.5. Turns out that that is exactly 3. So 3 goes here. So we will now need to figure out the x and the y components to those momentums. So this is for number 1 and this is for number 2. All right. So for number 1, if we want to figure out the x, that is the adjacent side. So I'm only going to do this for the first one, just so you see it. So I would be saying cos of 52 is x over 2.34. So I'll just multiply both sides by 2.34. So 2.34 times cos of 52 is 1.4406. And that is positive because that's the positive x-axis. Now I'm going to figure out the y, which is the opposite side. So I'm going to do the same thing, but I'm going to use sine 2.34 times sine of 52. And that's going to be 1.8439. And again, positive because it's in the positive direction. For number 2, the x I know has to be negative because of where it is on the Cartesian plane. And the y is going to be positive. So again, the x is cos. So I'm going to do 3 times cos of 61, which gives me 1.4544, but it's going to be negative 1.4544. And then to do the y, same thing. I'm going to do 3 times sine of 61. And that's going to give me 2.6239. And again, positive because we are in the positive part of the Cartesian plane for y. So when I add these together, here, 1.4406 minus 1.4544 gives me negative 0.0138. So number 3, in order for this to equal 0, has to be positive 0.0138. And so when I add those up, 1.8439 plus 2.6239, I get 4.4678. But again, in order for it to equal 0, we have to switch the sign. So I have that my x is positive, my y is negative, which would put me in this quadrant right here. So I know that the y is negative 4.4678, and I know that the x is 0.0138. So if I want to figure out what this is, and remember, when you figure out what that is, you're figuring out the momentum of piece number 3. So if I do that, I'm going to do Pythagorean theorem. I'm going to do 0.0138 squared plus 4.4678 squared. I have a syntax error because I did something wrong. There we go. And I'm going to square root that. And I get 4.4678. That is the momentum. But it actually asked me what is the mass of piece 3. Well, that's easy because the mass of piece 3 is the whole platter was 3.5 kilograms. Piece 1 was 1.3. Piece 2 is 1.2, which means piece 3 has to be 1 kilogram. So that part's easy. So if momentum is this, and I know that momentum is mass times velocity, so if my momentum is 4.4678, and I know that my mass is 1, that means that my velocity is also 4.4678. Paying attention to significant figures, that would be 4.5 meters per second. You may have something like 4.6, 4.4, depending on how much you round it off. Round off as little as possible. Some of you like to give me like 1.4. That's really going to throw your answers off. Be more specific than that. But velocity also includes a direction, so we're going to do tan theta is y over x. And so my y is this, my x is this. Again, I don't worry about the negative or the positive, so I'm going to do 4.4678 divided by 0.0138, and I'm going to do shift tan of that. And I get 89.8, so I really get 90 degrees. And that's going to be 90 degrees this way, right? Because it's in this quadrant. So it's going to be 90 degrees clockwise from the positive x axis. All right, so that's number 38. That was your homework on explosions. I'm going to do a couple of other videos tonight on the next couple of pieces in this section, and that will finish off this section.